Okay, hi, I'm Sam. I'm one of the volunteers with SeaJUG, so it's really great to see so many people here since we're going to have a really interesting presentation today. I'm really excited about it. We're going to be talking about full stack Java, so kind of different from what we normally talk about. I think I recognize most of the names here today, but in case it's been a while for you or you haven't, or this is possibly your first SeaJUG meeting, what is SeaJUG? So the Seattle Java Users Group is dedicated to helping you, Java developers or not Java developers. Basically, we just want to create a really vibrant community to learn about and talk about and contribute to Java and the JVM ecosystem. So we provide mentorship and career opportunities, and we have fun and build cool things and learn about cool stuff. So if this is your first time here or your first time in a while, please share the love, send those meetup links to friends that you think might be interested in, and invite someone new to the next meeting. We meet every month, usually the second Tuesday of the month. If you would like to volunteer with SeaJUG, now that everyone's getting vaccinated again, I'm hopeful that we'll be able to get out and do more meetups in person. So we'll definitely need more people helping out. So if you're interested, you can email leadership@seajug.org, or you could reach out to us on the meetup page. You can just contact us through there. If you would like to speak at SeaJUG, if you have an interesting project you've been working on or a technology related to Java or the JVM ecosystem that you'd like to talk about, please feel free to send us a proposal. We'd love to hear about it. Some useful statistics: we have over 2,000 members in Seattle.
And background is here.
For sure.
And yeah, so virtual meetings for 2021. Hopefully we'll have some in-person meetings soon, and depending on how comfortable people are, how stir crazy people are. And upcoming events. I don't know what we have upcoming for July. I don't know if that's posted yet. I don't think so, but we will post it pretty soon. Promise. Okay, logistics. Bathrooms are hopefully in your home. Hopefully you have a bathroom in your home, food and drinks. Hopefully you've had dinner, or normally we would provide pizza or some kind of food if we were in person. But yeah, the important part is the information and the connections that we make. So I just want to give a shout out and special thanks to JFrog for sponsoring this event. Really appreciate their support. Don't think we have anyone from JFrog on right now. Yes, but thank you, JFrog, for sponsoring this. Okay, moving on to the main event. This is Will Iverson. He is a frequent speaker at SeaJUG since I think way back 2011. So this is actually my first time listening to Will talk, but he has a ton of experience in the tech field. Will, I think I'll let you introduce yourself because you've just done so much that I don't even know where to start really. But yeah, so Will will be talking today about full stack Java. So Will, I think you should be able to share your screen. Let me know if that's not working for you.
So full stack Java 2021. So I guess just go ahead and get rolling into the presentation. So first off, a little bit about me, who I am, why I'm here, what I'm talking about. So I've been doing development since I was 10. I started out my career in Silicon Valley. I worked at Apple for a while as the Java and Runtimes product manager. At Symantec, working on Java development tools, including Visual Cafe. And in 2004, I moved up to Seattle and I joined up with a company called Solutions IQ, which is when I started doing consulting in this region. Written 4 books on software development, all Java-based stuff. And in 2010, I was one of the co-founders for a company called Dev9, which I was with for about 6 years. And we were one of the premium Java consulting companies in the region. We did a lot of web services at scale. We started building out some of what today you'd call the smaller, lighter weight frameworks like Play and Dropwizard and Spring Boot. And then also we were some of the first people to really start doing continuous integration and continuous delivery in this region. So in 2016, I was lucky enough to be able to sell my share of the company to my partner, and Dev9 has since been acquired by Nortal, which I think probably a lot of you guys know. So that gave me an opportunity to say, well, what do I want to do with myself? So I took a couple of years off to do a bucket list thing, which was to really learn game development. So I spent a couple of years doing Unity game development, and I launched a title called Blaze Sky, which is up on Steam right now. And it's a beautiful 3D game, and it was a lot of fun learning 3D math and shaders and graphics and perf tuning and all that fun stuff. So I shipped the game, and then in 2001, I found myself saying, well, what do I want to do now? I just spent quite a bit of time launching that game. I took it to PAX, and I found myself missing the Java space, in part because in practice, Unity is a lot like a fat app server. So it was, as I worked on it, it just got fatter and fatter and harder to work with. So I wanted to go back to building Java and also web applications. And so that sort of rolled into some of the questions about what and why to do a full stack app. And that's what led to the conversation that led to this presentation that I put together today. And so that started me thinking about a lot of questions. Things like, what does it mean to be full stack? What the heck is going on with the browser? I certainly suffer from having developed over the years a little bit of a jaundiced view towards the web browser and JavaScript, and we'll talk about that more in the session. And there was also even some questions about, is it even possible to be a solo developer and build a web app? Obviously, at Dev9, we were spending a lot of time working with corporate environments that were often very large, and so what does it mean to take a web app and scale it to that big team? And so then, of course, the final part, which came up when I was talking to a few people, and I said, hey, I'm going to do full stack Java, was if I was going to be doing a 300-hour presentation to cover everything from HTML, CSS, JavaScript, the history of web development, all that. So this presentation sort of represents boiling down a lot of these thoughts and questions that are on this overview into a single coherent deck. And there were a couple of bullet points for why I wanted to give this presentation now. One of them was the announcement that Google Docs was moving to canvas-based rendering. So I'm going to assume that, generally speaking, folks who are on this session right now as Java developers, you still have some basic familiarity with the web developments. You know what HTML is, you kind of know what the DOM is, you know what CSS is, maybe not in depth, but so when this announcement of Google Docs moving to Canvas, and I'm going to go ahead and click on this link and bring this sample up. What we're looking at here is, this is a Google Docs document, but this entire document is being rendered entirely through Canvas. So there is nothing about the DOM in this. And we can see I've got selections, it's got links, it's got images, tables, all of this stuff. So that sort of started me really thinking about, well, what in the world is web development even going to be? The next thing that came up as news was Internet Explorer 11 is now dead. Microsoft's announced that it's gone, and that represents a huge win for HTML5. So that means that now all of a sudden a lot of the things that we've been dealing with for the last few years about like that question of, oh, well, we can do web development, but IE now goes away. Slides after the deck. Yeah, absolutely. Slides after the presentation will be available. And then the third thing was, as I was doing research, I came across something that is now described as the hat stack. And it's basically a simplified model that really keeps HTML front and center, but allows you to build really rich dynamic applications, the kinds of things that I think of when I think of building a, quote, modern web app. So these three things all sort of intersecting came to me to say, okay, well, let's take a minute and just sort of think about what it means to be a Java developer, what it means to target browsers, and kind of pull that conversation together a bit. With the theme being, at least for me personally, can I be a solo Java developer and build a full stack app? And so that's the kind of thread that's going to go through this presentation. Doesn't mean that you're only going to work in as a solo developer, but is it even possible? So now I'm going to touch on 25 years of software development in 2 slides with what a application looked like before 2005. I think this is all going to be really boring review for folks, but I just want to put it on the table. In the old days, pre-2005, you could have a browser client, you could know HTML and CSS and a little JavaScript, talk to a server, which since it's SeaJUG, presumably you were writing that in Java. and then you'd have a persistence engine. So generally speaking, oh, the critics start already on my slides. Hey Samantha, can you mute whoever that is for me?
Yep.
Thank you. Okay, so this is like really, really basic old stuff, right? But today, if you said, okay, what does full stack development look like? And this is literally a question that I have friends of mine that are asking me who are interested in getting into tech. And it starts becoming this very complicated question. It's like, okay, well, React on the front end, but you want iOS and Swift for mobile and Android and Kotlin. Those are all going to talk in JSON to whatever your server application is, and then that's going to have a database, and then there also will probably be a million other little services that's going to be talking to, and all of that's going to be running on some combination of Kubernetes and cloud stuff, right? Could be anything, AWS, Heroku, whatever, right? Okay, so this, I expect that most folks who are in this presentation are actually pretty comfortable with the server part and the database part and already know about lots of APIs. And specifically for this session, we're going to really focus in on what I've got labeled here as the React portion. But it's basically the browser front end for an application. So what that means is that what I'm going to do is I'm going to take just a few minutes to kind of talk through the browser in today's world. So if you've been doing Java development for a long time and you started knowing the browser like a long time ago, let's just kind of baseline on where things are at today. So browsers, the first thing is that I'm going to call them browsers, but really we're talking about two specific runtimes. It's either going to be WebKit, which is Apple's underlying architecture for the Safari on both the phone and the desktop and the tablet, or it's going to be Chromium, which underlies Chrome. So what is a browser? It's an application. Most end users think of it as just a thing that you download and you run your browser. But what it really is it's the gateway to the entire internet for them. And this part here about how it is so successful and on literally billions of devices at this point cannot be understated. It's the reason why we're talking about the browser. And why is it so popular and cool? Well, even as a developer, it means I can just ship an app and put it up on the web. I don't have to go through an app store. I have to pay anybody any money beyond my hosting fees. And if we look at it over here, it's hard to really wrap, at least for me, to wrap my head around all of the things that a browser can do when you start adding it all up. It's got both the traditional document model stuff and the DOM and CSS, but it's also a complete multimedia platform at this point with HTML5, SVG and Canvas as vector graphics. There's 3D graphics, which gets into meshes and shaders and all this crazy stuff, all on top of not just one, but many networking stacks, right? So there's a lot going on there. Just as sort of a side note, things that are in the browser that you may not know about are also the printing engine, all the audio stuff, and one of the ones that cracks me up is there's even facial recognition now. So most of the browsers support not just being able to access the camera, but even being able to do facial recognition. So when I start talking about things like facial recognition in the browser, all this multimedia stuff, as a seasoned Java developer, the first thing I think of is this slide, which is basically, this is a snapshot from a website, Can I Use It? And it's showing the current state of feature availability. And sure enough, you see IE over on the side with a bunch of sort of scary reds and not really clear looking stuff and all these other browsers. And that's the first thing I always think of when I think of browsers. And this slide, or this particular graphic from Can I Use It, is a little deceptive. And if you do is if you flip into the usage side, what you see is something that looks more like this. So this is the graphic for Flexbox, which is the standard CSS way of rendering what you would think of as a responsive design. One clean design that just scales as you scale the window around. What you see here is that it's all green. It's very well supported. And you also see that there's only really, in practice, a couple of browsers that are even on the table. You've got Chrome, you've got Chrome for Android, Chromium, you've got Edge, which is now Chromium underneath, and then you've got Safari with WebKit. So generally speaking, the support for the feature set, as we talk about all the rest of this stuff going through, you should think of having come a long ways. So the next thing is the browser fast? I found this video. I've got a screenshot from the video here, where this guy is showing just a simple CSS animation. So CSS now has in it the ability to do both to do keyframe-based animations on percentages. So you can say, oh, I want to animate something to move and animate its properties. Here it's showing he's just taken a whole bunch of blocks of text. And then what he does is he demonstrates the difference between in the perf that he's able to get just by animating this graphic, having the text go up and down. In the animation that he does by changing the margin, so the bottom margin for the text, what he does is he's able to spike his CPU at 100% and get 15 frames per second. When he does the same animation, but by using these translate functions, which don't trigger a layout, he's getting 3% CPU usage with hundreds of frames per second. And it is, when talking about performance, this isn't even using any JavaScript. This is just simply the browser itself. And the reason that the perf difference is so huge is because a browser, in some ways, the one way I think of it is basically like Microsoft Word. It's got, when you use the DOM, you are laying out all these objects. And so if you change the DOM, that triggers a relayout, which causes a big perf issue. So thinking about is HTML fast, or what does that look like, you start getting into these questions of what are you trying to do and why. And then, of course, the last piece on that is the hardware. So if you have a piece of software like Chrome, and even if it's up to date and is deployed on everything from a 3-year-old Android phone, low-end Android phone, to a modern top-of-the-line PC, you're going to get wildly different performance characteristics. So now we've sort of set the browser high level, but the thing that makes the browser interesting is JavaScript. So as I'm sure many of you may know, JavaScript originally, 6 weeks is one of the timelines I've heard for what it took to implement initially. And of course, the name is very confusing. I won't rehash that now. But it's basically what you need to do any interactivity. And the way I think of it is as soon as you say, when an event occurs, I want something to happen, you immediately start getting into the realm of JavaScript. So that could be anything from the 2D graphics to the manipulating the DOM to fetching additional sub-information on a page. All of those things involve JavaScript. So JavaScript itself, as a Java developer, when I look at it, I often find myself getting a little bit confused or frustrated. A lot of the code doesn't look great to me, and a lot of that is because of the fatal flaw from JavaScript, which, like a 1991 Mac, JavaScript at its core is single-threaded. So what that means is that to maintain the illusion that the browser or the web page is responsive, you have to keep yielding. You have to keep giving the control back to the browser away from your JavaScript code. So most things that you want to do that are interesting and interactive in a browser, however, could potentially take time. You want to fetch something from the network, you want to render some graphics, you want to tweak the DOM to do some layout, you have to keep giving that back. So a lot of the confusing looking JavaScript to a Java developer is because you constantly are having to do the yields. So the original might be with callbacks in pure JavaScript. That gets then converted to something that looks like promises, and then that in turn has more syntactic sugar on it in the form of async and await. But as a Java developer, sort of observing stuff from the side, it can be a little confusing. What's going on here? So there's a video that was done called In the Loop. It was done, and I've got a link in the bottom. It's by a guy, Jake Archibald. You can find this, where he talks about the JavaScript event loop. And he has this really great visual. I just did a screenshot where he's showing the event spinning around. And hopefully this isn't screwing up everybody's Zoom too much, having this graphic spinning. But basically, when you're writing JavaScript, your code is mostly the JavaScript event loop is mostly just waiting. It's spinning, processing things that are happening, just waiting. But whenever something happens, there are two main things. There's tasks, which are the one side of the lane over here, and then there's also the render frame. So what does this mean? So let's say that you're working in JavaScript and you schedule a thing to happen later. Then it gets picked up. That might get picked up over by the task side, but when you're doing your task work, that means you're not doing the main loop, and you're also not kicking over to the render frame. So what that means is that if you have a infinite loop in one place, it will stop the rendering for the browser. Obviously, that's not good, and it's a very poor experience for the user. Now, by way of an example of this, even just something as simple as if you have a loop with a while loop and an animated GIF on a regular web page, that loop is enough to make the GIF stop rendering and stop updating. That's how sensitive the JavaScript loop is to pauses. Highly recommend the deck. And what we know about performance in the UI is that it's about perception. It's that feeling of, is this thing clicking back? Here's some articles where they're talking about how on the M1, that's one of the reasons why it feels really good over some of the Intel machines. It's because it's yielding quickly. So in JavaScript, same thing. You want to be yielding quickly. Okay, so that's a couple of really key points to think about for material that we'll be covering in a minute. We've got, just to recap, we've got a browser with the DOM, HTML in the DOM. We can tweak it with JavaScript. And this sort of leads to, in turn, some of the perspective on JavaScript from a Java developer side. So super snarky comment here. JavaScript is web devs figuring out things Java devs did 10 years ago. And if we think about some of the innovations that we've heard of, certainly as a Java developer observing that space, it's things like, oh, turns out you do want static typing. Oh, you do want build tools. Oh, dependency management. Having 15 different implementations of JavaScript, none of which are really compatible with each other, is not a good thing. So just like in the Java world, when we ran into problems, we would come up with frameworks and toolings to support that. JavaScript's doing the same thing. That's why we have a million JavaScript frameworks. And I'm not going to go through all the material on this slide in detail, but I think this is an experience that as a Java developer, when I look at the front end and I think about JavaScript, I'm constantly astonished at how quickly the frameworks appear, disappear. The joke is I started the tutorial on that, and then they already made it obsolete and decided to move on. And even things like Angular moving from 1 to 2, you see huge shifts in adoption and mindset. The worst case version of JavaScript is, hey, we have these JavaScript developers and they're inexpensive. Let's use them to build the backend. We see this continuing to get more and more complex with things like, now we're going to do client-side stuff, sort of, but we're going to talk to more backends. And then part of what also makes that frustrating is not knowing what JavaScript even is. When I go look on GitHub at JavaScript libraries and tooling, it's like I'm looking at completely different chunks of code. So all of this crazy stuff going on, rooted in trying to help cope with some of these fundamental flaws that came from JavaScript at the beginning. So that begs the question, if you sit down and you say, okay, well, I want to be a front-end developer, or at least have the option, and I'm a Java developer, what should I pick and use? So here are some of the classic things that you go check. JetBrains does reports, and Stack Overflow, and GitHub, and all these guys. Sort of cutting to the chase on it, when you look at the data, the closest thing I can see is that React is the #1 framework right now. People do like Vue, so Vue is definitely on the upswing, and the Angular's dropping. And on the server side, Java, it remains dominant, and you see Python starting to pop up a fair amount. So, okay, so you want to be a full stack developer. Maybe you've said you want to do React, so how bad can it be? This is a link to a GitHub repo that a guy maintains and it's intended to be helpful. They're roadmaps for how a developer can become a full-fledged, full-stack developer. But it's a little bit crazy. This is just his map for the front end. Now, I know that this is too small for you to read, but what you can see is a long, winding track on here, with one block on this one being JavaScript. This is the track for React. This is the track for the back end. And just to highlight how crazy this is, that's Java. It's just one little block on here. That's relational databases. So cool, you've learned front end, React, back end. Now you want to also deploy it. And oh, by the way, here's the guidebook for DevOps. And so in order to feel like you're a good developer, oh, I should also have Kubernetes and Docker and everything else thrown into the mix, right? So it's a bit exhausting. And it's not surprising to me that a lot of people nowadays would just say, I'm done. I'm out. I don't want to deal with this anymore. I have talked to several developers who are close to my age recently who've just flat out said, yeah, I don't want to do this all anymore. They're exhausted by this constant stream of all of this stuff that they're feeling like they're supposed to be on top of. And part of this is, and this is where I find guides like this to be a little frustrating, is because the message I think that people can walk away with when they start looking at all this is that it is actually very distressing. It's too much. You always feel like you're missing out. You always feel like you're not really on top of it, or you're never going to be able to stay on top. And it can be very frustrating. And part of what makes this even scarier is that constant feeling that, maybe you just say, look, I'm a Java developer. Okay, well, what happens if Python becomes the new thing, or React, or the database stuff? In the database here, I put Oracle as an example. I know a lot of Oracle DBAs and Oracle architects who really bet their whole career on that platform, and they're watching that sort of drift away. So this problem of all this complexity has kind of led to the model that we have for most of the teams today. I don't think that most of the developers necessarily would put this way in public in front of their peers, but I think a lot of the back-end side has basically said, look, I'm just going to build back-end services. I'm going to focus on things like the data complexity and the deployment system, and I'm just going to send JSON to the front end, and then I'm done. I don't have to deal with browser testing. I just want to build an API. And this is where a lot of Spring Boot apps, I think, wind up being actually built and used in production. And then on the flip side, then the front end is basically said, okay, you just do your front end thing. You build your Angular, your app, whatever. You build it, you test it, ship it, do whatever you're going to do. You can have your Java team, your Swift team. They just sort of split. So this is a terrible joke about the use of React. The joke is that somebody's betting their whole career on a JavaScript framework created by Facebook. What could possibly go wrong? So what I'm going to do is I'm going to take just a few minutes, again, because this is a Java development group, to sort of look at React, especially from the perspective of a Java developer, just so we kind of are all up to speed. This is from another presentation by Thomas Gutierrez, I think. I don't know how it's pronounced exactly, but it's a great talk talking about HTMX, which is a tech I'm going to talk later. And I like this quote, which is, React looks like in-browser PHP. So what does that mean? So this is what I call sort of React in a slide. What we see here is a little chunk of JavaScript code here, where it's just formatting a name. So it takes a user object in, first name and last name, and concats them together. Here's just a constant, first name and last name. This is the interesting part here in some ways, which is I've got my element, which has got a header, and then it's calling the function to drop the user in. And then this is the render. So it's saying, let's take this, render this, and drop it onto the root object. So what we're looking at here, and in practice, React in some ways winds up kind of feeling like, is just another system for doing templating, just like you do with Timeleaf, except now I'm doing it in the browser. Over on the side here, we can see this is just straight from the React tutorial. It talks about this a hello world, and then JSX, which we'll do on the next slide, is their way of doing this templating system, rendering it, components, and events, right? So this starts to feel kind of familiar. And what's interesting about it from a performance standpoint, if you think about like talking about the DOM earlier, is what React is doing is it's compiling this Java syntax here into its own little chunk of code to then dynamically build the DOM from this. So it's a little different from just concatenating a bunch of strings together and then you send it to the browser. Here, what's happening is React is taking that those chunks, and then it's using that to build JavaScript, using JavaScript to then build the DOM dynamically. And that's cool, right? It's got components, it's got rendering, it's got properties, and it's stitching all those things together into the browser. And those components are the reason why people wind up getting excited about React. So this is another little chunk of a slide from a YouTube video where somebody's talking about why they love React, why they love it so much. And basically what they're doing is they're talking about how they're building out these trees of components in the browser. So that's all being done with JavaScript, and you can install a debugger tool, which will even allow you to now see those components all in the browser. You can see their properties, their state, their rendering system, see all those pieces stitched together. That virtual DOM, that component tree, the one that we've got here, is part of what then leads to one of the most important technical aspects of React, which is something called the virtual DOM. And basically what they say is we've got this tree of objects that we're maintaining. We don't want to thrash the DOM a lot, because if we remember from earlier in the session, we were talking about performance implications. So they use a virtual DOM to avoid updating. That means that now you have two that you're maintaining. You're maintaining both the actual DOM and the virtual DOM, and this is part of where the complexity starts coming in, because of how React is managing that DOM versus what's actually in the browser. So it's pretty interesting. It's got component system. The components are conceptually based on HTML, but it's really HTML by way of JavaScript. Because it has this component model, that's where the third-party support starts to kick in for things like being able to drop in additional components. And of course, one of the nice things about React is it has gotten enough momentum that if you want to see a tutorial or, add something into it, you can find stuff. And it is possible to add a React application incrementally to a page, but generally speaking, idiomatic React, from what I see most often, people are just saying, well, React's the thing that's controlling everything that's going on. The other one is, and this is probably the thing I keep hearing when I talk to people about this stuff, is that they're just tired. Like there's a new framework every week, and that a lot of the front-end developers are like, I'm going to use React. It's a standard thing now, and I can work with it. Which is why when something like Vue comes along, and I see that its adoption numbers start to come up, I see people start to get that sort of like deer in the headlights look again. Just to kind of highlight the complexity, this is the component lifecycle for React. We're not going to go through the slide, except just to sort of say it's got components, they're mounting them, they're rendering, and then they're updating each other. Now, of course, as a Java developer, when I see that, I remember this slide. So, all right, let's see if anybody can guess what this slide is in the chat. See the first person who can guess it. Anybody? It's very similar, right? It's got views, you're applying values, processing events. Anyone? So, boom. Okay, George, JSF. This is JSF2. This is a JSF2 slide, right? So this is sort of that joke about it's 10 years, right? So this is a slide from 2009. It's 2021. Kind of makes me laugh. And where this is another example. So on the front end, this is something I remember seeing is all these front-end frameworks, both Java ones and now the JavaScript ones. Web development's hard. Let's create a framework. We're going to do fancy things with properties, which is part of where the complexity comes in, and all of these things. And honestly, for me, what I think of and what it reminds me of is the same thing that we went through with SQL. We said, oh, talking to relational databases is hard. We'll have all these frameworks and tooling, and we're going to have caching systems and all these things. And it just got exhausting. And at least in the Java world, frankly, I wrote a book on Hibernate, right? I like Hibernate. But in practice, what I found was things like the caching systems made things really, really hard and complicated. They made things harder, not easier, for almost everything I was trying to get done. And so what happened on the relational side is, most of the time, I'm now just using my thought. What question in the chat is, what do I think about Python? That's like another whole presentation. So what I found with the Java side was that I wound up using basically Spring Data JPA repositories. I throw annotations on for queries, and I'm done. And I can show that to even a pretty junior developer, and they can follow the stack and see what's going on if something goes sideways. And it's just fine. It's really not that bad. The same thing I found when looking at this HTML stuff is that maybe instead of going all this full way with everything like React and Angular and Svelte and stuff like that, maybe there's a way to back off on that a little bit. So that then segues to the question of what the heck is this hat stack that you're talking about, right? So there are a couple of frameworks that comprise the HAT and hat, HTMX, Alpine, and Tailwind. And the big idea around that is that it's HTML and the DOM, and that's what we should be focused on. And we don't necessarily want to have every single thing that we do be entirely revolving around the JavaScript side. Sending HTML fragments is the thing that maybe we should be doing instead of JSON for everything. So HTMX, Alpine, and Tailwind all start really focusing on just adding some additional attributes to your HTML to accomplish your tasks. And so that concept of, well, maybe we should just send some fragments over, and maybe we should not be doing so much complexity. I first found an essay on that, and then I started running into some implementation. So here's Hotwire. So this is a package that the fundamental premise is we're going to, instead of using so much JavaScript, we'll send the HTML. Then there was another one, which is Unpoly, saying same thing. We're going to kind of minimize how much JSON. There's a really great deck that was done, and this is on the Unpoly site, where somebody's talking about, like, we built these really complex front ends for a lot of our applications, and the vast majority of them we didn't need it, and now we built things that we can't even maintain. And here's the one that really cracked me up. So this is a post that was put up on the React working group for React 18 talking about the new server-side rendering architecture. So what they're saying here is, and these are just a couple of choice quotes from the announcement, was that they're allowing you to now generate HTML on the server and then send that to the browser. And they're saying that, hey, this is cool because now you can see the content of the page before the JavaScript runs. And basically they're saying, well, the problem is if you just drop a ton of JavaScript down onto the browser has to finish building and compiling and rendering all that stuff before the user sees anything. So they're saying, well, if you use server-side rendering, then you can avoid having a blank page. So now the React guys are saying, well, we're going to send HTML from the server to the browser. So all of these things, I'm like, okay, well, if you start seeing the same pattern showing up in several different places, maybe this is worth looking at. So it's not that complex conceptually. It's instead, if the old standard way is you send JSON over, which gets parsed, generated HTML, and added. Now we're just going to send the HTML, which can then get parsed and slammed into the DOM. Both ways, at a minimum, you still have to incur adding the HTML to the DOM as you make changes, but one way you have to do all the HTML parsing and JSON in the browser. So HTMX is the first library that I found that really made this trivial and easy. So the idea here is with HTMX is here's a little tiny library. And what we're going to do is we're going to use that to allow you to access all these complicated, fancy, fun things that you want to do by making your web app, but we're just going to do it with a small number of attributes. And so here you can see, like in HTML itself, if I click on a link with an href, or if I have a form, those are the only things in the browser by default that generate HTTP requests. Well, why can't I do that with anything? Why can't I update portions of the screen? So by simply adding a few additional attributes, you're now able to do all of those things. So here's an example of what that might look like. This is the most trivial sort of version of this. So this is just HTML for a button. But we've added a few attributes. We've said, okay, well, when I click on this, I want to do a post. And that post is going to hit the clicked URL on the server. And when whatever comes back, that HTML, I want to swap that into the target div. So it's very simple. And what's funny about this to me is that when I first looked at it, I was like, well, okay, cool, but how powerful is this? And what I found as I went through the material was I was like, oh, this actually covers a huge percentage of what I'm actually trying to get done. So these are some of the examples on the HTMX website, and I'm going to go ahead and just hit the link real quick to bring it up for live demo. So here we can see things like click to edit. So what I'm able to do now is, here's the sample code, which is mostly HTML. I want to hit this, I can edit something, and then I hit the save, and I do all of that dynamically where it's updating the form just with adding these few attributes. Some of the other ones that are more interesting perhaps include something like infinite scroll. So this is a pattern that you see all over the place nowadays. I just want to add infinite scroll. I want to be able to keep seeing content because I never want my user to go away, right? This is kind of a pain to do with a traditional JavaScript framework, but with HTMX, I add a few attributes. So whenever this is whenever the element at the bottom is revealed, then go ahead and fetch the next result and swap those in at the end. And so here I can go ahead and download scroll, and we'll notice that it's even got a little indicator, and that's provided as part of HTMX's feature set. Is I can just say, here's an element that I want to display as the indicator when I'm scrolling. So imagine as a server-side Java developer, if you're used to working with, if your boss came in, or if you have a cool startup idea and you wanted to add infinite scroll, how much work would that be? With something like this, it's really trivial. So there are other demos for all sorts of other things, and we'll come back and look at the Java version later. And sure enough, there are a bunch of these patterns like lazy loading and updates and editing, where I found, oh, look, these are things that I need to do all the time, and having to go and learn all of React just to be able to do them is not something I'd necessarily want to take on. So these are all the server-side implementations where people have posted different programming language with implementation showing how to use HTMX to integrate with it. So HTMX is just a front-end network, front-end platform or library. Here you can see all the backends, and a couple of these are sort of like blasts from the past, like who's doing web development with Prolog. But I think it highlights how flexible this is for integrating the front end and the back end. And then the other scenario, which I've even been using myself for mockups, is I'm now able to do my mockups in HTML, and then when I want to do subpage level refreshes, I just add a couple of annotations, and now I can grab, even in my mockups, very trivially, subpage updates and things. Same thing with animations. I don't have to worry about doing JavaScript for a lot of my animations. I can just simply add a couple of annotations, and now all the animations work. Now, of course, one thing that I hear is, well, I don't necessarily have access to be able to get HTML back. I'm still going to get JSON back. And so here's an example of using HTMX with an inline template tag. So the template tag is actually just a standard HTML tag, supported by all the browsers now. And what it tells the browser is, hey, here's a little chunk of code or a chunk of text that I want to treat as a template. So don't render it when I send it, but it is available to be fetched. So here what I'm doing is I have a div with a button in it, and the button, when I click on it, fetches data from a JSON API, and then it then uses a Moustache template to then display and render the result set, the JSON that comes back. Now I've omitted for clarity things like the debug, like error handling and the putting up the little icon to show that the fact that there's a fetch going on or something like that. But you can see how easy this is and how it's an HTML-centric way of looking at things, not a JavaScript-centric way. So I just mentioned Mustache. Mustache and Handlebars are just standard, pretty simple templating systems, and one thing that's neat about them as opposed to something like, say, Timeleaf, is that these templates are available with a ton of different languages. So basically all it's saying is, here's an object, here's a template, stitch them together, and then you can produce text. So you might use that for HTML or email or whatever. I don't have time to go into all this in detail in this presentation, but here are links for things like, how to use Handlebars with Spring Boot or React or HTMX or whatever you want to do. So just as a sort of a side note, this is a thing you might want to check out for having a common lingua franca for sharing templates between platforms and stacks, which as a side note is supported by IntelliJ. And so here's a Timeleaf show, or a Handlebars file being opened up in IntelliJ, and you can see it's got things like completion and error checking and stuff like that. So HTMX, in my experience, covers, for when the stuff I'm working on right now, covers about 80% plus of the tasks that I'm trying to accomplish. I just add a few annotations and I've got rich interactive capabilities. But there are still things where you want some fancier stuff happening in the browser. And I've found two things that I like that represent this. One of them is Hyperscript and one of them is Alpine.js. Hyperscript, and actually we'll get into both of them really quickly. Hyperscript is a scripting language where the idea is that you can either do it in script separately like you can with anything else, or you can just add an annotation on which adds the scripts, kind of like a regular onClick, but you just use underscore equals and then you add in the scripts that you want there. And what I like about it is that it's very, very terse and very, very readable. And what's happening is under the covers, it's still compiling this back down to JavaScript, but it's taking care of all of the complexity around things like async and promises and stuff implicitly underneath the covers. So I don't have to write any of that into the Hyperscript that I'm writing. So by way of example, for a comparison, here is a div, and for the sake of the example, I just want to be able to click on the div and have the div disappear with an animation. This is how you do that in vanilla JavaScript. So I have an onClick handler, and then I'm hooking into request animation frame, which was one of those sequences on that event loop that we saw earlier, setting its opacity, waiting for the transition and remove. It's very clunky. This is the jQuery version, which is actually better, but still kind of clunky, and this is the same thing in Hyperscript. Very, very readable, very, very easy to understand, and it's the sort of thing that is much, much closer to self-documenting, i.e. if someone found this line later, they could see it and understand it much more easily. Alpine.js is another framework that is based on this notion of just adding small little annotations to get a lot richer functionality. So here what we can see is a JavaScript component where it's being declared with the, let's see if I can find my mouse. Oop. Okay. Here I can see I've got a little chunk of HTML. I've got an xData, which is attaching some data to the component, and then I'm adding on a click handler to be able to open and close it when I change the property, and then the xShow is the property being tweaked, and now it's changing the content. So this is a lot more powerful than, say, for example, just using HTMX alone, but it's still sort of rooted in this idea of I'm just adding a handful of attributes and properties. So you can see here, there's only 14 attributes in Alpine, so it's very easy. I feel that somebody could sit down and learn Alpine in a day, pretty trivially. And then finally, the last piece of the stack, which is Tailwind. So Tailwind is a new CSS framework, and people are really compare and contrast it with Bootstrap. The simplest way I can think of to do that comparison is to say, okay, well, Bootstrap tends to think more in terms of components like cards and buttons and things like that. And Tailwind is saying, look, we're going to apply control directly to the thing you're trying to build by just adding additional classes to it from their directory. So that's a whole topic in itself, and here's a great link to a YouTube video on the topic. So one question I get when talking about this stuff is, can I mix and match them? Sure. The short answer is yes. And the only tricky part is initialization. So if I say, well, I want to use React and HTMX together for some reason, you could do that, but you'd want to make sure that when the React is building its stuff, that it's also letting HTMX know that it's added a piece of content. And that's part of that complexity, especially on something like React, where it's controlling the whole DOM itself. So since we're Java developers, part of what we're here to talk about is how does all this stuff work with our Java apps. So I have a demo app that I put together with a Spring Boot app sitting on top of this stack. And so just to kind of orient on what is involved in that, so the first piece is how did I build all this stuff, the demo or the code that we're going to look at in just a minute. So I prefer Maven over Gradle, so I use Maven for building this. I'm using WebJars to pull in all the NPM packages. So what that means is when you go to look at a JavaScript library, the very first thing that they all pretty much say is, hey, here are the coordinates to pull it down off of NPM. So as a Java developer, I'm used to grabbing Maven coordinates. So what I do is I go to webjars.org, I pop in the npm info, and it generates a Maven artifact for me. It's pretty slick. So what that means is I can pull everything in that I need, and I don't have to actually even install npm or node or any of that. If I needed to, if I just wanted to start doing Sass, there's a plugin which is listed here. But if I said, hey, if I did want to start adding in fancier stuff into my Maven build, I can use this Maven plugin. And then there's JHipster, which is another whole separate thing. So the Spring Boot app, which this is the link to the demo that I'm going to show. The main branch is basically just illustrating some simple ways that I'm using HTMX with Spring Boot. It doesn't use anything fancy, no Sass, no npm. It's just simple. And then in the dev branch, I think somebody's taken a bath or something. In the dev branch, I've added in support for tying in Spring Security. So it's got auth and some core stuff, and then email reg and all that. And that's also to support things like once I log out in a session, it will auto log you out in another browser window, all tied in with Spring Boot. So what I'm going to do is going to go ahead and open up IntelliJ. So this is the demo project up on GitHub. And let's look at a couple of things here. So first of all, when we look at the project itself, this is the full-blown one, so we don't really care about the security stuff at this point. What we see here is I've got my tests, like I'd expect. If I open up the POM and I start scrolling through it, you can see this is where I'm actually pulling in all the things that would classically be pulled in by npm. So I've got my Hyperscript, I've got Bootstrap, I've got pulling in some icons. I'm using Assert4j for my tests. I'm using Timeleaf to generate the basic guts of the app itself. Here's how I'm pulling in Mustache or Handlebars. So it's just sort of a standard POM. Any Java developer should be able to take a look at this and kind of see what was going on. And it even does things like dependency updates when I run Maven site. So it's just a standard Spring app. I've got one thing. Let's go ahead and run it so you guys can see what this is all about. So one thing that I'm like anyone should grab from this project is I tone the default Spring Boot logging way down, which makes it way faster. So now it's running. So this is just my little basic demo thing here, and we can see that I've got the Java versions of some of the stuff that we saw in the HTMX. I use Bootstrap, but it's the same basic stuff here, including stuff like the validation, which is this is actually just the browser validation. And then here's infinite scroll. So if we look at this, we'll notice that it's actually displaying the little loading icon in the bottom corner with my infinite scroll. So this is a good one, I think, to take a look at for how I actually did this. So this is the HTML for this page, and there's very tiny. There's almost nothing on it, right? Just starts with the loading and a couple of attributes. What I am doing is I am pulling in a layout fragment, so I can go here. This is part of Timeleaf, and this is because I don't want to repeat myself. So each one of the separate pages that gets rendered, the host pages, has this being included in the page. And this is where I'm pulling in things like, this is a Timeleaf lookup for pulling in Bootstrap, for example. And I've got the loading indicator, which is the little image that's showing with the spinning circles. There's just not a lot of code here. And if we go back in and we look at the controller for this, so this is the entire thing. The only thing that's like slightly fancy is I do add the annotation to just say, yes, I am producing HTML and sending that back as the response. And if we go into here and we look at the network, we can actually see, let's go and reload the page. As I'm scrolling through here, we can actually see the pages coming back from the server. Now you might say, well, why is this taking 500 milliseconds? And that's because I have a thread sleep. Because if I didn't do that, we wouldn't have enough time for the thing passing to be able to draw the image. But all I'm doing is building a little string back, dumping in some random context from a data generation library that I'm using, and then responding the HTML, sending the HTML back. This is the worst version of the way to do this, which is I'm just using string interpolation, but I still get code completion and everything by telling it it's HTML. If we look at some of these other examples, let's see, so click to edit is using timely for templates. Let's see, input catalog. This is one of the more larger ones to look at. So one thing I did do was I said, okay, let's look at everything, all of the HTML input types. So buttons, checkboxes, SVG icons, controls, files, all this fun stuff. And what I did was I did a implementation where this is able to take each element and in real time ping it back to my Spring Boot server and then get an image, get a response back. And here I'm just going to slap the response back into this box. So as I click on buttons, set the checkboxes, click on the icons, if I set the range on things, there we go. It's sending back the inputs on all this stuff. And a couple of these, like color, for example. So color is going to generate browser-specific things, or browser-specific UI controls. Same things for these date and time widgets. You get very different widgets depending on the browser that you're using. Either way, in the Spring Boot controller for this, I'm showing how to take this that's coming back as dynamic stuff, going to the server, and then pinging and updating in the browser. So pretty slick, simple stuff to be able to get things like, here's a search. So this one has a key up delay on it, which means that as I type in search, it then will ping it. Here it's sending the search value back just into the server message, but you can imagine how this would instead come back to a drop down that might give you selection values or something. So you can see see how all these UI components come together. And if we switch back over to the controller, this is just a little demo controller, so it's showing, here's the button, right? All it's saying is, hey, I clicked on the button, and then it responds back with a paragraph saying that the button was clicked. This little P is coming from a templating framework that called J2HTML. So it gives me the ability to send back type-safe HTML. Alrighty. So that was showing how simple and easy it is to take stuff that you're doing with HTMX and tie it back into Spring Boot. It's the same controllers and the same things that you've been working with for some time. And that starts to give us a path to what a solo Java developer, I think, could probably manage. If you said, okay, I'm going to do Spring Boot, and I'm going to still do timely for whatever templating I want for the main pages, I can use fragments, and I could do them in HTML. I could either send back straight strings or handlebars or J2HTML. I don't, for anything that's not just a simple thing, you're going to want escaping, the HTML escaping. So you do want to use something like handlebars or J2HTML. You can use something like Postgres for deployment, for persistence, and you can deploy with something like Heroku, which is really simple and easy and has detailed instructions on exactly how to deploy Spring Boot apps very easily off of something like GitHub. So that actually makes for a pretty good stack, and between things like Hyperscript and HTMX, you can get something that will seem to an end user like a very rich, robust application. So that means that you're focusing on the HTML. I would submit that HTMX is so simple, and so are things like Hyperscript and Alpine, that you could have your whole dev team come up to speed on them pretty quickly. One nice thing about how many years do you give before? So one of the questions in there was, how many years do you give HTMX before it's as bloated as React? So that's actually funny, because the guys on the team who do HTMX, they're very explicit about saying that they kind of view HTMX as pretty close to quote done. They have an extension mechanism, so you can still add in your own extensions to do other things. But they sort of feel like it does all the things it's supposed to do at this point. They're working on Hyperscript as well, and Hyperscript is the one that's definitely getting a lot more of the crazy cool features, tweaks, and stuff like that. I would note that one advantage of HTML fragments as a communication tool over JSON is that it almost always forces you to include thinking about the actions that are being performed on the data as well as just sending the data back and forth. But that's kind of getting into the weeds a little bit. Okay, so we covered a lot of material here. Let's talk about next steps. So first of all, here are a bunch of the things that we didn't cover yet. We didn't talk about Canvas and SVG-based applications. So I opened this with talking about how Google was switching off of Google Docs being done through the DOM and instead doing it with Canvas. And so we didn't really talk about that very much. Same thing with SVG. So SVG allows you to do vector-based HTML apps, and there's no reason that you couldn't actually do pretty fancy stuff with that. But depending on what you're trying to do, that's either a brilliant idea or a terrible idea. Another thing, just to touch on briefly, is content management systems. So one of the things that I've found is that, like, I have a Squarespace website. That's what I use to host all my personal websites. I can throw HTMX at the top and then throw some includes on to add in the rich dynamic thing that I want very, very, very easily. So that actually works out really nicely, and that's part of this whole bridging strategy as you scale it out. The other ones we didn't talk about, the desktop mobile native app side of things. So there's a whole world of Swing and JavaFX, which I could do a whole talk about. There's also Electron and Electron-like things, where you're either literally bundling in Chromium, which is what Electron does, and then there's a couple of others where they're basically saying, well, you can build and deploy a desktop app, but the app is basically relying on the built-in OS browser to be able to take care of things. And then, of course, progressive web apps, which is basically HTML apps adding in even more and more rich desktop and mobile device integration features, which is like another huge topic. What I would suggest for someone who's who's gone through this presentation is like, okay, cool, this is kind of interesting. I actually like the idea of being able to build a whole app from beginning to end by myself again. Check out the sample that I put up. And then the other one is, I would say that before I'd even look at anything like React, is just make sure that you're up to speed on what you can do with contemporary modern HTML and CSS and JavaScript. There are a ton of things that you can do just even with CSS that years ago you would have had to do really complicated fancy JavaScript, and now it's just built into the browser. So, and like when I sort of showed that feature slide earlier, this might even be a thing that you could go back into work if you're in an environment and say, look, IE11 is down to less than 1%, less than 0.5% of the current deployed base. Maybe we should rip a bunch of the old stuff that we've been doing to hack and fix that. Here are a couple. The Mozilla Developer Network has been huge for me for going through all this stuff. And then on YouTube, here are a couple of the YouTube channels that I've found that have had great material to cover. So drop IE11. Explore some of these new libraries and tools. And what's funny is you can even go into the JavaScript world and say, look, I'm looking at server-side rendering for HTML fragments, and you'll actually be the hipster kid, which is kind of a cool flip around. And then, of course, check out Handlebars. I think I mentioned that earlier because it plays nicely with all these different things. And with that, took about an hour to get through the core material. It's now a little after 7. Time for Q&A. So I just threw my email address up there. As a side note, if anybody wants to reach out, if they'd like some support or have somebody come in to do a brown bag or something, although I don't know, I'm fully back, so I could come in for a face-to-face brown bag or do a video chat or something like that. Feel free to reach out to me, or even if it's just somebody say hi, because I recognize a lot of you guys' names in the chats here, so it's good to catch up. So wiverson@gmail.com, and I'm also posting a lot of this stuff up on Twitter at my Twitter account, because I guess I'm cool. And there you go. So that's my quick blitz through front end. I know I covered a ton of material really fast. I have some back pocket slides if there's anything in particular that people wanted to ask about. or just take open Q&A. I know. So I'm going to go ahead and stare at the chat window intently here, see if anything pops up. All right.
That's a question using voice.
Absolutely. Good to see you.
I will. I'd like to get your thoughts on what you think the significance of that. I mean, that, as you say, the fact that Google Docs switching to Canvas seems like that's a very profound decision for a company that huge for such a complicated app. Like, what is that saying to you? I mean, what's your conjecture as to why they did that and what that means?
Yeah, that's a great question, and it's funny. Like the background on this is like compasses and vector lines. It's all about prediction, and so like predicting, where this is going. Here's kind of what I think is happening is that there's a world of apps that people want to build where it's content delivery, right? And it's a document, and it works really nicely with the DOM, right? The box model, complex layouts, complex renders, where you say like, hey, I've got a bunch of these objects and I want them to all flow properly and scale as a resize. I think part of the issue with what Google ran into, and this is just conjecture on my part, is that they were fighting that layout engine all the time, right? They wanted to control how everything got laid out. They wanted to control when it was getting laid out. And once you start saying like, okay, well, I'm spending all of my time fighting that DOM model, then I just want to render. Which begs the question to me of at what point do other companies start offering things like, just hypothetically, a visual builder like tool that lets you do drag and drop, components, and you can do a theme UI and all that stuff, and all it's doing is just generating WebAssembly and Canvas underneath, right? Is that a good thing or not? Depends on what you're trying to do, right? Like, in practice, what I see today is that most of the things that are punching and doing Canvas, people are pointing out Flutter is doing that. Flutter just says, yeah, we're just going to blitz stuff to the canvas. If, for so much of the web where it's like, I'm just, here's a blog page, here's a news article, whatever, that works fine for the DOM. How many people are going to build apps that way? I'm a little concerned that I suspect that a lot of business folks are going to come in and start wanting people to build apps like that probably shouldn't, because they really are content apps. But who knows? Is that good? Is that bad? There are two tools that I would check out if you're curious about Canvas and you want to know what you can or can't do with it. I would check out something called Construct, which is it's ostensibly a game development tool, but it's also just a web development tool that blitz on Canvas, and they do all the optimizations. They're going to generate all the assembly and stuff, all the underlying guts, and it runs really fast, and they target mobile and desktop. So if you wanted to build a Canvas app, you could check out something like Construct 2, or they have an open source version, which is gdevelop, I believe is what it's called. Let's see, I think that was one of my pocket slides here. So yeah, playing with Canvas, gdevelop and Construct, those are the ones that I'd check out for that. And then on the graphics side, just as a side note, so today there's WebGL, so you've got Canvas, and then you can back Canvas with either a 2D blitter or a WebGL blitter. The WebGL one is basically OpenGL, but kind of the mobile version. It's like OpenGL, yes. I forget which version. There's like a whatever. They're already working on something called WebGPU, and the idea is that instead of being OpenGL, it's going to be closer to the way that Vulkan and Metal and Direct 3D work. So that will allow you to target that higher end of performance. That does make the gap that much more brutal because, I've got a 3-year-old Android with some integrated video card at one end, and I've got my, NVIDIA 3080 with TI on the other end. Like, what are you even trying to target or do? I personally think that a bunch of the stuff with the SVG is really, really interesting. And if I had the free time, I would say, it might be worth looking at building out an example of like what a SVG-based UI system might look like, where it would do the layouts and everything, and you could do components that were SVG based and have windowing system right like that. But there you go. Xamarin in its place in full stack and mobile dev. Yeah, so basically, here's kind of what happened. So I built this game in Unity, and the game got huge. I mean, it was compressed 2 gigabytes. My whole my whole repo, my whole GitHub repo with the LFS on it, it was like 10 gigabytes of assets. Graphics, sound effects, it's probably something on the order of about 3 or 4 hours of fully voice-acted material. It's a giant space opera RPG. It's really cool. You should check it out. It's cool. But it got huge, and building it and deploying it, like one of the things that was nice was that when I wanted to do the deploy on a Unity title, the way it works is you build the game in Unity, and then you can deploy it to Steam, and you just can write some command line scripts to automate that process. So the whole game can just get pushed out to Steam, and then I'd log into a UI, and I could hit deploy to the beta channel or what have you, and then the Steam client worked really, really well. I could get crash reports back from Unity, and I could also get analytics from both Unity and from Steam and Valve. It was really cool. But then I was like, okay, I don't really want to build a 10 gigabyte thing that takes an hour to build, right? I want to go try building some smaller apps. So I started exploring things. So I looked at, and I wanted to be open-minded about it. So I looked at every cross-platform desktop and mobile framework I could find. So I looked at Qt. So what's Qt looking like nowadays? I looked at, on the Java side, I looked at Swing, and I looked at JavaFX, which was part of the JDK and is now blown out. I looked at Xamarin, and like Xamarin, for example, they have a very sort of like primitive UI system that you can use for cross-plat UIs, and then they basically were like, but if you want to build it that looks for realsies, what you're really doing is you're using Xamarin to build stuff on top of Objective-C or Swift-like stuff. You're just building a Mac UI, but you're using Java or Mono as the language, but you're really just building a Swift app or something. So as a Java developer, I'm spoiled in that I like the idea of I write my app once. I mean, that was why I liked Java in 1995, was I could say, create a new window, add a button to it, and it worked great on the Mac and on Windows. So that wasn't super satisfying to look at things where like Xamarin, where I didn't feel like I was getting good quality for what I was doing. When I started looking at like things like JavaFX and Swing, the communities for those have gotten really tiny because of just people aren't doing that sort of stuff now, which is too bad. I actually built a template. So if you go up onto my GitHub account, I actually spent some time and I built this thing. So this is a little template that lets you build a JavaFX app where it actually uses GitHub to build the native installers, the Mac and the Windows and the Linux installers for your JavaFX app. And it just uses Maven to do that. So I even wrote a little Maven plugin to make it work and everything. But I just sort of kept coming back to this problem of like dealing with the updates, and the people who I want to use my app, even getting them to download and run an executable or a disk image is still more weight than it is to just say go to a URL. So that's kind of where I wound up drifting back to the web. And then there were also a lot of little things about, how far along is JavaFX on it, and is it have the feature set I need? Same thing with Swing. Active-J, that sounds very familiar. Replacement for Spring, Quarkus, Micronauts, and other solutions. So I haven't looked at Active-J yet. I know, between Quarkus and Micronauts and some of these other stuff that people are building alternatives. Originally I used stuff like Drop Wizard and Play Framework back when it was like its kind of 1.0 before it went Super Scala. And I don't have personally I don't have problems that this would help me with right now, because as soon as I get off of Spring Boot, then the world of support starts shrinking, and I found Spring Boot to actually be really fast, especially when I do things like turn off the default logging. So it doesn't just, I'm not just watching the terminal scrolling banners. So I don't do anything that requires me to then say like, oh, I need to look at something like Quarkus or Micronauts, or I need to do native image builds, or I need to do reactive. I'm cool. I'm cool. I don't need to worry about reactive. I can wait till Project Loom comes along and makes it obsolete. It's cool. Vaadin. Yeah, I've looked off and on over the years at Vaadin for years. So Vaadin is a UI framework for building apps. And it's fine. I don't know. It's got kind of a funny model where you have to pay for some stuff and not for other stuff. Charts and things. I guess where I feel like so many of these things start to get weird or interesting is when they're trying to recreate native UIs, and then they sort of go sideways, versus saying, well, I'm just going to build a UI that's my own control of the canvas and blitz stuff out. Like here you can see things like it's got full screen. It's actually got the Mac UI, but it's a material design look. Is that what a Mac user wants, or are they okay with that? I don't know. When I was working with Unity had a really robust cross-platform UI framework that let me build my own UI widgets and stuff, and that was fine for building a game. How much do people care about fidelity to the native OS or not? And is it... I'm going to back up for a sec. So when you're a solo dev, you don't have the time to build all the things. You can't... It's very difficult to say, well, I'm a solo dev and I want to build a mobile app, a desktop app, a web app, all of that stuff. And so you kind of wind up saying, okay, well, what do I need to do to be able to get the thing working and building? And depending on what it is, like if it's a game, then maybe, yeah, you just use Unity. But for generically speaking, I would say that the browser is probably your first target anyways. And that's kind of what pulled me back to stuff like HTMX and the web, because as a solo developer, I can still deploy a thing that I can use on all these devices and desktops and stuff fairly easily. Does Vaadin work for you? Is it Flutter? People on the chat were just having Flutter scroll by. I don't know. Just depends on what you're trying to build. Serverless, AWS Lambda, Azure Functions, GCP Cloud. Have I looked at that stuff? Yeah, I mean, serverless has been a thing that's been sort of floating around for several years now. And the way I'm doing work right now, I'm perfectly fine building and deploying my Spring Boot apps because it's a single coherent piece of work. There are things where I could see putting them out as serverless functions might be nice. I know several years ago, there was a team that we were talking to where they'd kind of built like 1 million microservices, and what they found was that they were running into management problems with because this was like 6-7 years ago, and they were like, well, we'll just let people build microservices or with whatever platform they want to do. So they had like a Python person, or they'd have a JavaScript on the server person and a Java person, and what they found was that they couldn't manage it. It got away from them. Usually my project, especially as a solo dev, when I do a project, I want to have one thing that I can open up in IntelliJ and have everything kind of there in one place. And then I would look at starting to break that up into separate repos, into separate stacks, and breaking up into maybe things I want to put as a serverless function. That's something I would tend to look at more once I kind of have validated that the thing I want to do is a thing that I want to be using more. Heroku, I can get full server and the database and everything for $10 to $30 a month. And so if I'm doing a thing that I care enough about to even be testing and telling people to hit $20, $30 a month, and I get all the things I want, isn't very much money. Like if I'm going to put 40 to 150 hours of dev time in something, then $30 a month for the hosting to figure out whether or not it works versus trying to min-max that to get it on a serverless thing is like, whatever. Okay. So so to try to like make it as tight as possible, like why do I like as a solo developer just use Spring Boot and then throw out HTML fragments? I get all the things I want to do, which is I can like, it's very easy to write test cases. It's very easy to do the build. I'm working in one IntelliJ project, and I'm not breaking up how I'm doing my work into multiple projects. Like my worst case scenario is I've got a React project and my server project, and I'm constantly having to manually keep those things in sync with each other. That's kind of a pain. As soon as I say, oh, I want to support the mobile app, the mobile, iOS app, the Android app, the React app, and whatever, then yeah, I'm probably going to want to just be building JSON APIs and spitting those out. And I think part of this is this sort of inherent tension of I'm building a small app because as a solo developer because I want to get something working today and it doesn't do what I need, versus the eventual architectural decisions that I might be making if I had a team of 15 developers that's supporting me. And that's a progression path. And I do think that there is something to be said for having that be a seamless path, right? Like I could say start out with this one model and then over time as I go through it, manage that progression in a coherent way. As sort of a side note to that, one of the things that I think about a lot when I'm thinking about architecture is how the architecture support team development. So, like do the repositories, do the workflows match the teams with the architecture that I'm trying to build? So I think that's part of where, that starting out with the solo, but have a clear path for how this could go up to how do I build and maintain a thing with 100 developers working on it. So hopefully that helps. It's a transition path as you go through it. Another question: CI/CD toolchains for my full stack. So depend on the situation is the core of everything, because that could be, am I using Canvas or DOM? Depends on what you're trying to build. Are you trying to build a game or a CRUD app? I mean, those are completely different things. So that's part of why my joke at the very beginning about this being a 300-hour presentation, because it's like I'm going to talk about how all of web development in an hour. Like, sure. Let's see, CI/CD tool chains. So yeah, I mean basically. So this is where it's kind of funny. Like there was a time when setting up a CI and CD deployment system, it was like, well, I've got to have my Jenkins machine running under my desk. And literally some of the first times I was using Jenkins, I was having to like get a machine running under my desk and get special permission from my client's IT department to even have a server running that people could hit. It was like ridiculous. Today, you can actually go in with GitHub Actions and set up a perfectly reasonable approximation of a nice CI system with a few clicks. There's examples of this up all over my GitHub repos. So I've got public GitHub repos. So you can go grab even the pretty small little like Maven. How do I do a Maven test run with GitHub Actions for free? Trivially. And then for the deployment side, the easiest thing to do is like if you're just like a solo dev who just wants to get things working and you're using Heroku, you can actually point Heroku right at your GitHub repo and just make it, if you want to do continuous deployment from your GitHub repo to your Heroku environment, you can absolutely do that, and that's just a few clicks. Do you want to set up a production one off of main and a test on your dev one off of dev, and you could just say, yeah, every time I do a deploy to dev, I want you to update the server environment. That's easy. One of the things I will note is that as a solo dev, I pay $5, $10 a month, and then you don't have to build out your IT plumbing, right? That's huge. This stuff's all so cheap. GitHub is cheap. GitHub's free. You can put your documentation up on GitHub pages. Throwing a few bucks for Heroku, no big deal. I don't know if it's Caton or Cotton, but I'm glad that the talk was helpful for you. That's awesome, man. Alrighty. So we're coming up on 7:30. Let's see if we got any more. I think I got everybody's questions in here. Let's see. Test containers also. Yeah, so Garrett, hey Garrett. So test containers. So this is actually like kind of an interesting thing. So what I've been doing on mine is I have a Postgres instance running on my Mac, and I just use that as sort of my persistent test thing, and then I use Spring Profiles to basically be able to target that, or just use H2. And what's funny is I used to say, oh, well, we use H2 because it's faster and lighter than Postgres. What I have found is that my builds are actually, it's the same amount of time to run it against Postgres as it does against H2 on my Mac.
Good at just $15 a month. So, as Mint's new...
Somebody's plugging Mint Mobile. So firing up a stack with Selenium, there you can do that on yours, and then if you're doing like a local Selenium instance, that's where you start getting into stuff like that might be a real no-brainer for using something like Docker to do that. But there's also like a whole bunch of web services out there that do maintain Selenium grids, so you can also point it at that as well. So you don't. I think one of the frustrating things is like, I think Docker's really cool. I think that's an example of something where it's right on that fine line of like overwhelming, especially a new developer or a solo developer, for how far do you want to go down that stuff. But as soon as you said, like, as soon as your complexity starts getting more complicated than, the browser, a Spring Boot server, and one persistence engine, then you immediately start getting into like, well, yeah, now you're going to probably be looking at Docker or Kubernetes and test containers for things, because you don't want to be, putting, I don't know, Redis on your local machine and tracking that separately. You just want to go ahead and use containers for it. So off the cuff. It's this tension about like how much do you say, if somebody wants to build it, has a cool idea for an app, how much do you make them learn, or how much do they have to learn to just even get that? And this is gonna like. The thing, I remember the first time I wrote a web page in like 1995 or whatever, and it was just really cool to get to see I wrote this thing and now it's displaying, and I throw a HTML page up on Apache and I have a website. Like, that's really cool. And it's that creative aspects. And part of what it is to me is like, how much stuff do you have to do to even get that creative itch scratched? Like the to-do app, right? That's like the hello world of 2021 is a to-do app, and what are all the things that you have to do to get that done? Applets. Yeah, applets were just before Flash. They were like, Java could have been Flash, but nobody at Sun cared. They didn't want to invest in it. So Macromedia swept it all away with Flash. Alrighty. Man, it's good to see the faces on the screen that I can see. It's too bad that we can't get to meet face to face. Hopefully, and at some point in the near future, we'll be able to do a face to face. And if there's any of these topics, that you guys are interested in that I've touched on, that might be a fun thing to come back and talk about. So, any other last call for questions? 7:30. I think we're supposed to all at least.
Thank you so much. Do you want to pull up the slide with your contact info in case anyone wants to follow up with you?
Sure.
And so we've recorded this, so we can share the recording. And Will, you said it's okay to share the slides too?
Yeah, sure. They're PowerPoints. I can either throw them up on SlideShare and give you guys a link, or I can just post the file or whatever. I got kind of crazy with animations and graphics, so it's probably like a 30-40 megabyte file at this point, but whatever. Mm-hmm. Yeah, my email address is wiverson@gmail.com. I've got a good spam filter. Life goes on. So
great, thank you so much. It was really interesting. Thank you. And everyone, thanks for coming. And we will have the next meetup posted soon. Have a good night.
Thank you. Take it easy, guys. Bye.
Well, thanks. Bye.
Good stuff, Will. Thanks.
My pleasure.
Bye-bye.